All right, good morning, everyone. Today we're going to be talking about HTTP and how to make requests with over Ajax requests with fetch. So let's go ahead and start. Here in this slide deck, we have HTTP, the web's protocol. HTTP connects the world, Hypertext Transfer Protocol. That's what HTTP stands for. The protocol was originally described in 1991 with the origins of hypertext dating back to as early as 1930. And here is an example of what websites used to look like. It was originally created for college to be able to share information effectively or efficiently with one another. And essentially, it was just a connection of different HTML templates with one another to be able to display information. All right, moving on to the next slide. All right, can I get somebody to read this slide, please?
The HTTP protocol was originally designed as a protocol for transmitting hypertext. The modern equivalent of hypertext is HTML. Today, HTML has grown to support much more than just linking from one page to another, but it was a concept of linked pages that uniquely defined the early web. HTTP has also found new use cases. While transmitting HTML is a common use, HTTP can transfer any type of document or file. Today, HTML isn't even the most common type of document transmitted over HTTP. Images, CSS, JavaScript, API responses, etc. are far more common.
All right, fantastic. Thank you, Chase. So, just like this mentions, probably JSON is going to be the most transmitted kind of document that goes over the web. And we're going to see that here when we start speaking to our API. Essentially, there's many different types of documents with information that are sent over the web. There was a question earlier when we talked about the doc type about, well, hey, what kind of other documents are being shared? JavaScript, JSON, XML. There's plenty of other documents that are being sent over the web from one another, and mainly have to deal with the front end kind of, excuse me, type of document that is being shared. All right, so then we go with hypertext. So now here's an HTTP conversation. HTTP conversation describes a conversation between two parties. A client contacts a server. The client sends the HTTP request and the server sends the HTTP response. Both HTTP requests and responses are plain text. They're easily read by human and each has a very simple structure. All right. So this one's pretty simple. I log into my site. I go to www.facebook.com. A request goes to a server saying, hey, I'm trying to grab my Facebook information. And a response comes back with an HTML template saying, hey, here is all of the Facebook HTML that you need to be able to render, along with the data that you need to be able to iterate through to create the content of what you have on your homepage. All right, with that said, we'll start talking about requests and responses. We have a short little example of what they look like on the left and right hand side. So there we have a request for an HTML template, which is a GET request from the hostexample.com and the user agent being Google Chrome. And then we have the response being returned from the server on the right hand side, which that tells us the status, the content length, the date in which the response was completed, the content type, and then the response itself being an HTML document. We're going to dive deep into this information here shortly. So now, the request line. Get is the method that was for the request, the URI being the slash bio.html, and then the protocol version being HTTP, meaning Hypertext Transfer Protocol. There's also HTTPS, which stands for Hypertext Transfer Protocol Secure. All right, moving forward. The request line. Common HTTP methods or verbs include get, post, put, delete. We're going to dive into these more in depth once we get into our Django applications and start making our actual APIs. Essentially, what this stands for is for CRUD. Get is for receiving data or reading data. Post is for creating data. Put is for updating information, and delete is for deleting information. This is also known as CRUD. HTTP methods is something that we don't necessarily have to dive into just yet, but please keep this as an Easter egg. They exist, they are there. Put it in the back of your mind and carry it all the way into Django. All right, so here we go into the request line and we have the Uniform Resource Identifier, otherwise known as the URI. This is what comes after our web address. So we have http/example.com/bio.html. Here is our Uniform Resource Identifier. All right, so the URI. There we see the example, the request, and we have a couple of examples of URN and URL. URN being the host plus the URI, example.com/file.html. And then we have our URL, which is the protocol plus the host plus the URI. And now we can see that we have hypertext transfer protocol by example.com at bio.html. Right. HTTP request. We have the request line plus the headers. In the headers, we can see the host and the user agent. There's a couple of other headers that we can dive into, but we're not going to talk about that just yet. All right, can I get somebody to read this slide here?
Just like the bottom right.
This entire slide. And go ahead, Jack.
HTTP request with body. So you have a request line, you have headers, you have a blank line, you have a body, which is optional, uh, and a request. And note, request bodies are most commonly included with post, put, patch, and delete requests, and can include all types of content like images, and form content, etc.
All right, fantastic. So here it looks like we're looking at an e-commerce site. In this e-commerce site, when this request is sent to grab information from the server, it looks like the information that they're grabbing is anything related to new Jordans, along with the Jordans being a color red. And we can see that on the query on the lower left-hand corner.
What is patch? The patch request?
Apologize.
On the previous slide, on where it talk in bottom right says post, put, patch, and delete. What's patch?
Yeah,
Update.
so patch is a different type of request that can be sent over HTTP methods. It's almost like a get, post, put, and delete. We're not going to talk about patch throughout this cohort, but it's definitely something that you can look into on your own time. Does that answer your question there, Jason? All right, I see the thumbs up. Fantastic. Now let's talk about HTTP requests with query parameters. Oh, right. And here we can see, hey, there was a search being done. The moment you see a question mark, that question mark means, hey, the following are arguments. And here we see our key value pairs coming in from a form, being a query, being equal to Air Jordans. This percentage sign 20 is the equivalent of saying a space. And then the color is equal to red. It's all happening within the URL so that we can grab it from our form data. And we looked at an example of this yesterday when we were walking through how to work with forms with JavaScript. So additional request data can be included as part of the URI instead of being included in the request body. There we can see the request or the search parameter being transferred, the question mark, saying, hey, the following is going to be parameters, and we can see the query params within key value pair. So query parameters are separated from the URI with a question mark, and individual query parameters are separated by an ampersand, or excuse me, that I believe that's called an ampersand. Query params can be combined, and the request bodies. All right, we're going to see a little bit of request bodies as we start working into our Django module. We're not going to go too far into that just yet, but just know that that is an existing possibility. Does anyone have any questions over this slide here in particular? Or up to this point? Perfect. Doesn't seem like there are any questions, so let's continue. Request headers. Can somebody please read this slide here?
Request headers provide additional context about the request. Some examples are host,
example.com tells the web server which domain the client is requesting content from. Often a single web server will serve content from multiple domains, sometimes called virtual hosts. The server this uses the server uses this header to determine which content to serve. Accept language EN. The client lets the server know which languages it prefers the response be sent back in. User agent Google Chrome 53.2. Which type of client sent this request? Sometimes the server will respond differently based on the UA field. Accept text/HTML, text/plain. What format response is the client interested in receiving? HTML and image JSON.
All right, awesome. Thank you so much. So we'll be seeing an example of headers here shortly once we start working within HTML. And you could also see it if you start messing around with different APIs utilizing Postman, which we'll cover here at the end of the lecture. All right, well, what about the HTTP response? This is from the server side. Everything that we've seen up to this point has to do with the requests, and the request is coming with JavaScript itself. Now, the response is going to be coming from our Python server that we created with Flask. The response specifies, hey, this was processed correctly. So we'll get an HTTP 200 for OK. We'll get the content linked. How many characters are actually inside of the body? In this case, it's 424. The date at which the HTTP response was completed, and then the content type, which in this case we see text, HTML. Sometimes we'll see text JSON. Sometimes we'll see text XML. There's a couple of other kinds of files that can be returned over the web as a response. So there's the response status line. We see the status code of 200 OK, and we're going to see different types of status codes once we dive into Django. Here's a couple of examples. Response status codes such as 200 OK, 302 see an other link, 400 bad requests, 401 unauthorized, 404 not found, and 500 internal error. A couple of the main ones that we need to make sure that we realize, 200 means the request was successful. 400 means the request was unsuccessful, and this is the client's fault. 401 just means you don't have permissions. You're not logged into the correct account. 404 means whatever you're looking for does not exist. And 500 means this is not the client's fault. You did everything right in making your request. There's just a coding error within the server that I've made a mistake in. Does anyone have any questions regarding status codes? Perfect. I'm not seeing any questions. Let's move on to the next one. And let's have someone read this slide here, please.
Response headers. These headers serve a similar purpose as the request headers. They provide additional context that the client uses to interpret the response. Common response headers include content type, text HTML. What format is the response body? The client uses the header to properly parse the response. Content length, example 492. How many bytes long is the response body? This header tells the client how many bytes to read from the network socket. Set cookie, currency USD. This header requests that the client save a cookie with a particular name and value. And date, Friday, 22 January 2010 at 4 General Mountain Time. When was the response sent?
All right, fantastic. It's pretty simple. Something that we need to take a look at here is the set cookie function. We're going to talk about the set cookie function later on, but essentially what set cookies or cookies do in general is data being saved within the server that is being transmitted to the browser to tell the browser, hey, this is how information is to be rendered within the screen for this specific user. Now, you may think to yourself, well, this is something pretty simple. Why are we setting it within the cookies rather than sending it within something as simple as the body or the request body? Let's take a look at GitHub here. In GitHub, I'm going to go ahead and inspect. I am going to come over to this application tab. And in application, there is this cookies tab. And if I click on it, you'll see that there's quite a bit of cookies being displayed. Now, this is all within GitHub. I'm going to go ahead and refresh this just so that we can see it happening one more time. All right. Now, within the GitHub, I have this user session. So it's saving the session that I'm currently using. There's the saved user session, the preferred color mode, whether I'm logged in or not. And there's a couple of other things that are happening within that application tab that is just the server itself telling my browser, hey, save this information. And you can see that it has a couple of check marks over here saying whether it belongs to the host, if it's safe or if it isn't safe, and then what kind of safety protocol to utilize, which here we can see we have lax, which stands for relaxed, standard, and neutral safety protocols. A couple of different ways to be able to set cookies. Don't worry about cookies too much. Just know that it is a secure way for the browser, or excuse me, for the server to tell the browser to save information regarding the user without exposing this information within the request itself. All right. Can I get somebody to read this slide, please?
Many HTTP conversations. Imagine a user browsing a few pages on a typical website. Dozens or hundreds of HTTP conversations will take place. Loading the homepage HTML, one HTTP request and response. Loading CSS, one HTTP request and response per CSS file. Loading JavaScript, one HTTP request and response per JS file. Loading images, one HTTP request and response per image, and that's just for a single page.
All right, great. So let's go back to our example of github.com here. And now instead of looking at the application tab, I'm going to go ahead and come over to the network tab. So the network tab will show us all the different types of requests that have been sent and within milliseconds and their status. What kind of text was returned as well. I'm going to refresh the page here for github.com. And as the page becomes requests or as the page loads, we can see it from 0 milliseconds all the way up to 500, 2000, and at 4000 milliseconds, it looks like the majority of our requests have finally been completed. And if I scroll with this timeline bar, it's going to show me all the different requests as they're happening and what's being executed, what's not. If I scroll down, as soon as our request is sent on our browser, or within our 4000 milliseconds, we can see that there was a request sent to public APIs, which returned a document of 200. We can see a couple of different requests being used through fetch. And they request different TypeScript files. We continue to come down. We can see there's a couple of collections. If I take a look at something like Google and go to the network tab, we're going to see the same exact behavior. So there's Google. Here's a couple of different requests. If I go ahead and refresh it, it tells me, hey, here's all the 200 requests that were sent. We see that there's a document, a script, a couple of different style sheets that have been rendered just for Google, more JavaScript scripts. We see we have a couple of SVGs that have been loaded. We continue on. We have PNGs, GIFs, a pretty ridiculous amount of information that was all requested over a matter of milliseconds to be able to just generate this 1 page right here. All right. And we're going to talk about how all of that is happening here shortly once we start looking at our own example. All right, I'm going to go ahead and take a pause here before I continue on to the next numbers of information. I've been covering quite a bit so far. Does anyone have any questions over the information that I've just covered?
So as we're making the request, the okay, if we were to be seeing the URL, so when we type something in, it sends a request, and the URL we get back is the response, or
Yeah, so when we type in the URL, we're sending a request on the site that goes over to the server. The server then processes the request and sends back a response. Kind of just how we did in our Flash server here. All right, so here we have a Flash server. If I run it, let me go ahead. And then open this Flash server. So a request is being sent from my browser to HTTP 127.0.0.1 at port 8000. That request is being received through my server here. And then what my server is returning is HTML with an H1 of Hello Zulu. And here we can see, hey, the process of the response was completed at this date. It was a get method, and the status for this request is 200, meaning I have sent back a successful response. That answer your question, Kenny? I see the head notes. Fantastic. All right. Can I get someone to read this slide here, please?
Stateless. A very important characteristic of HTTP is that every conversation shares no state with any previous conversation. Every HTTP conversation begins with a new connection from the client to the server. It's as if the two parties are meeting for the first time. Every request made just moments before have no bearing on the current request. Server state. Most servers clear all state variables with each request. This means all state when processing a request come from the request itself.
All right. Awesome. Thank you so much. So let's talk a little bit about what exactly does that mean? All right, so a client is being rendered or a client is logging into their home screen. When the client logs in, it sends a request to the server. And what this request looks like is, hey, can we talk? From there, the server will respond with yes, we can, or no, we can't talk. And this part of the conversation happens without us seeing it. We see, yes, we can talk. Finally, there is a request from the client saying, well, hey, since we can talk, can I have some information? The server then grabs it from the database and returns it in JSON saying, here is the info you're looking for. And then that gets displayed by the client by either iterating or displaying it within HTML. All right, so there's the HTTP conversation that is happening, and this conversation is happening every single request. It is double checking if they can speak to one another and then asking for information. Nothing is being saved. There's no variables happening within this transfer protocol that is being saved. Information may be saved within the database, but in the actual conversation itself is as if these two have never met each other ever, every single time there's a request being processed. Does anyone have any questions about that? Fantastic. It doesn't seem like we have any questions. Let's move on here. So stateless HTTP cookies help retain state like who is logged in or what was their last search across multiple requests. This might sound like a total violation of stateless nature of HTTP, but even with HTTP cookies, HTTP as a protocol remains stateless. It all has to do with how HTTP cookies are being implemented. Again, HTTP cookies are the server being returning a response telling the browser to set specific variables. Nothing is actually being saved within the communication itself. It is being repeatedly sent over every single response from the server. So it doesn't violate our stateless mentality. All right, cookies in short. Can I get somebody to read this slide here?
You'll learn more about how HTTP cookies work, but for now, here's a summary. The server sets cookies by sending them to the client as part of the HTTP response. The client stores the cookies. The server does not store any cookies. Any cookies for the current domain are sent to the server as part of the HTTP request.
All right, fantastic. Thank you, Noah. And as we saw in our previous example here within GitHub, let me go ahead and go back to my GitHub example here. I come back to my application, take a look at some cookies. I'm going to refresh it. As I refresh it and requests are being completed, so we all saw this being blank for a split second. When it's blank, it's the initial render. Once requests are being completed, meaning that the server is returning responses, every one of those responses, or the majority of those responses, may come back with cookies that are to be set within the browser. The browser essentially takes a look at that set cookie function and then places it as some information that is to be saved regarding this one user, such as the user session, the time zone that I'm in, and whether I'm logged in or not, even to the point where it even saves my preferred color within the session. All right. Summary. HTTP is a proven protocol. It's extensible and has found uses far beyond what was imagined in 1991. It's relatively simple, human readable, and easy to parse with code. HTTP first changed the world by connecting users and servers to form the web. But today, it's the foundation of so much more than the web. You'll soon realize that HTTP is everywhere. All right, fantastic. And I believe that's going to conclude our slide deck here. Before we go into our break, does anyone have any questions or anything that we covered up to this point? We're going to take a look at HTTP a little bit more in depth once we dive into the second portion of our lecture and actually start writing some code to seeing how to send requests and how to receive responses from a server. Okay, perfect. It doesn't seem like we have any questions. Now, this second portion of our lecture, it's very important that we are fresh for. So as of right now, it is 9:31. Let's go ahead and return at 9:50. It's going to be a whopping 15 minutes. Let's return at 9:50 and continue with part 2 of our lecture. Thank you so much, everyone. And I'll see everybody back here shortly. All right, welcome everyone. In part 1, we just finished speaking about what is HTTP. There's this public APIs portion. You can go ahead and just, if you take a look at our curriculum, you're going to find a link to all of these public APIs, but I'll go ahead and share them here as well so that everyone has the ability to interact with them. I'm going to send them over the Zulu questions channel. If you take a look at that site, there is a ton of APIs that you can interact with. You can control F it and take a look at something in particular that you may be interested in. I personally like a lot of these APIs that are available. Not all of them require some sort of authentication. If you take a look for some that don't have authentication on our HTTP secure, more than likely you can interact with them over just a simple JavaScript file along with some HTML. All right. So there's a little quick dive into that. Now, for part two of our lecture, we're going to actually talk about how to interact with APIs, what are async functions, and do a quick review over the full stack lifecycle to connect the dots over everything that we've done up to this point over this last module. Now, let's take a step back here and go into interacting with APIs. Well, I've already shared this information regarding this API. In today's example, what we're going to be utilizing the most is going to be the Poke API. Now, in the Poke API, when I send a request, I'm able to grab this information regarding any Pokemon. Well, now that I have this information regarding any Pokemon, and I know how to work with forms, and I know everything that I know about JavaScript, I'm going to simply write some code that will allow me to have an input field, collect the user's information, grab a Pokemon's info from this API, and then render an image on the screen. So how can I do that? Let's take a step by step. How do I write a form that will receive users' input?
Just do the form, and in the form, put the input field of text.
All right, perfect. Let's go ahead and do that here. We're just saying to create a form, and in this form, have an input type text. Do we want any sort of placeholder?
Yeah, I guess like you could say put a Pokemon name or something along that line.
Go ahead and do
And
Pokemon name.
you also want a submit button or just a normal button, whichever works.
All right, so let's do input type submit. Oh, hello. All right. Is there anything missing, any attributes missing inside of this input field in particular here on line 15?
An ID?
All right, I could also add an ID. What about something else?
On line 15 specifically,
Yes.
A value.
All right, we could dictate a value, but what about a key value pair? When I go to create those key value pairs, what usually gets interpreted as the key?
oh, the name.
Perfect. So let's add a name here and make it Pokemon. All right, let's take a look at our field. So here's our script now, or HTML script. Now showing us Zulu. We know that our CSS is being connected because hello Zulu is now in orange. And I know that my JavaScript file is connected because if I take a look at the console, we're going to see this. We are connected coming from a JavaScript file. All right, great. So now I have my form. How do I make a function that will be able to capture this user's information?
If no one else is gonna answer, they can if they want. But in form, I would create like a class so that you can create a function when it's clicked. Yeah, on submit.
So an on submit function, and let's do this called get Pokemon, just like that. And we could even pass in the event. Great. So there's my get Pokemon function. Let me go ahead and open up main.js as well and leave index.html to the side. Excuse me, everyone.
I'm
All
sorry.
right.
When we pass in the event, like for there, the event would be the on submit, right?
Yes, correct. It would be a submission event.
Okay.
I
Oh,
have a quick question too.
yeah, of course.
What's the difference between using on submit and then versus like setting a class name and then in the JS file setting a variable equal to the form value and saying like form equals document dot query selector form, and then on doing an if like form dot event listener. Is there like a preferred version? if that makes sense.
Got it. As far as under the hood, as to what's happening, the latter of what you described is what's happening under the hood when you utilize an on-submit method. Now, as far as a preferred method, it's kind of all semantics. They're both working the same. Um, I would recommend utilizing an on-submit function to identify the event and make it readable for other developers. Unless you're writing an entire website in only JavaScript and then turning all of that into HTML, just write the on-submit method on the form itself online, on the actual inline block. Does that answer your question, Chase?
Yeah, that does. So just a cleaner way. Thank you.
Of course. All right. Awesome. So now we have this get Pokemon function, but it doesn't exist. How do I create this get Pokemon function to be able to capture users' information? And let's pass it on to Jason Anderson at this point. You're muted.
I'm muted. You would do const get Pokemon in the JavaScript file,
All right.
and then equals yeah, and then squiggly brackets, and then the input is user input. So you would do you let user input equal document dot user input dot value.
Okay. This is definitely a good start. So now, very first thing here we have on our get Pokemon function, we're passing in an event. Why are we passing in the event? What is it about a form's behavior that we have to handle whenever we are messing with an event that has to do with a submission? And let me hear this portion from Morty.
I really don't recall, but I remember it's like a default thing, right? Like to change defaults or something like that, or
Yeah, changing the default behavior of that submission.
default behavior. Yes.
Perfect. So we're going to actually pass in the event into our function, and we're going to prevent that event. All right. Now, the next portion that we have here is our user input. It looks like what we're trying to capture here is going to be the field itself. So let's go ahead and do user input field first. And how would I grab that? Let me hear this portion from Rachel.
You can do document get element by ID,
Okay.
and then whatever you name the ID on the HTML user input dot value.
For now, we're grabbing the field. Now we can grab the value.
Okay.
Absolutely. All right. So now we have the field itself. Great. There's a couple of other ways that we can work with this form. We could definitely use form data and be able to grab information, but this is a way that works. 100 ways of skinning a cat. This works for now. So now we have the input field. Now I want to grab this request. Well, before I do so, let me go ahead and make sure that I'm actually getting this input field information. So let's go ahead and grab this user input field dot value. I go ahead and place Pikachu. I submit, and we see Pikachu being displayed on my console down on the lower right-hand side. So this is working like I want it to. Well, now comes our function that we want to set. I'm going to create a function here called fetch Pokemon info. I'm going to go to the Poke API. Here in the Poke API, there's a couple of different ways that I can go ahead and grab this Pokemon's info. I can put an ID, and it would return the information regarding Bulbasaur. I can also place the name of a Pokemon, and I can send it to return the information regarding one specific Pokemon. There's also documentation that I can take a look at. And I always recommend that when you are interacting with a new API, you always read their documentation. All right, so here we can see some resources, some endpoints. We can see a couple of different API endpoints that we can interact with. They have information regarding berries. And here it tells me, hey, this is what you can interact with to grab berry. It gives me an entire URL. And that URL, then it tells me the parameter. The parameter that I can pass in is either an ID or a name. And that's actually pretty cool that they are giving me the option to interact with either an ID or a name for most of these MPI endpoints. All right, so now I know how to interact with Pokemon. Let's go ahead and grab that. I'm going to copy this to my clipboard, that URL altogether. And then this fetch Pokemon info, this is a function that is going to grab my Pokemon's info. I'm just going to go ahead and do, hey, we're going to receive a name here. I'm going to make my URL. So request URL. And I'm going to make that equal to and paste the URL. The only thing I'm going to change is instead of passing in Charizard, I'm going to make this into interpolated string for receiving the name. And there's my request URL. So basically, regardless of what I place in here, it is all going to populate to show me my request URL. All right. And let's go ahead and console.log request URL. Now let's pass it in here. Let's do fetch Pokemon info request, or excuse me, user input field dot value. Let me come back to my site here. I go ahead and place Pikachu and I submit. And there we can see we have HTTPS, Poke API, API v2, Pokemon Pikachu. If I go there, it gives me this entire JavaScript or this entire JSON file, which is the response from the Poke API. All right, great. We're working towards the ability to be able to generate this image. Does anyone have any questions up to this point over what we've done? How we're connecting the dots?
For the user input field, couldn't you just attach dot value at the end of that? And that way, when you call the fetch Pokemon info function, you don't have to put user input field dot value because it would already be set to that.
I definitely could. The main reason why I haven't is because I want to grab the actual form itself so I could reset the attribute value once the submit button is clicked and reset it back to a blank value. Does that answer your
Okay, yeah.
question?
Yeah, that makes a lot of sense. Thank you.
All right, awesome. Okay, so everything's working. We're grabbing our API, or excuse me, we're grabbing our information. But what if I want to send this request now? How do I send a request with JavaScript? Well, I send it utilizing fetch. I'm going to say, hey, I want to fetch the following. I want to fetch from my request URL. And once I request this information or I fetch this information, I'm going to grab the response from the server. And what I want to do for now is I want to console log the response. All right, let's see what happens when I send my request now. I click on submit. Well, now if we take a look at the response, it comes back as an object, what I request from the request URL, which is what we created together. It's just requesting from Pikachu from the Poke API. That's what fetch is doing. It's sending the request from my HTML document to grab information from that browser. So this first two here, I never saw them. They happened, but I never saw them. Where my request was sent, saying, hey, can we speak? The server said from Poke API, yes, we can speak. And then my JavaScript file said, I need the information regarding a Pokemon named Pikachu. The server queried the database, said, select all from database where Pokemon name is equal to Pikachu. Once it got back all that information from the database, it turned it into a JSON document and then returned it to my JavaScript file as a response. And that's what we see here in our console being displayed. Does anyone have any questions about that so far? All right, so the response comes back in my console. I can take a look here. And here we can see a couple of the response headers. We can see if it was okay. We can see the status. This is great. Well, now I can do a little bit of handling here, right? If the response's status is equal to 200, then I can move forward. And we'll talk about error handling here as well here shortly. Well, now this data, although I received it, it's not something that I can really work with. And I want everyone to understand that this .then is essentially grabbing the return value from the previous function. So this request URL function returns information. That information that is returned is being passed to the .then function as the response. So now let's make this response into something that's JSON readable, something that I can work with. And I do that utilizing response.json. And then I can .then pass in data. And I can finally console.log data. Let's take a look at what's happening here. Submit Pikachu, I send it. Well, now when I take a look at this object in my console, I have the same exact thing that's being displayed here in the Poke API. I have the abilities, I have cries, game indices, etc., all the way down to sprites. All right, so here I open up the object, abilities, cries, game indices, all the way down to sprites. Everything that is stored inside of that database is now being returned to my JavaScript file. One more time, I capture the user information through the form here. I send the value of said form into my fetch Pokemon. Once the value is sent, I generate my request URL. I then fetch information from the Poke API. The return value of this function is being set to the .then method as the response variable. That then gets turned into JSON readable information. This is a function. You can see .json has open and closing parentheses, meaning this is a function. It returns a value. The value that it returns gets stored as the variable data inside of the next .then method. Data is then logged onto the console, and that's how we get this object here on the far right-hand side inside of my console on the web. .then is only grabbing the return value from the previous function. Now, why do I need to specify it that way? Why can't I just set it to a variable? Well, this information here, as you can see on the example that we drew, there's a whole conversation that happens. Not only does it happen at this level, but we also need to give time And let me clear these drawings here. We also need to give time for the server to be able to speak to the database. For information. Although I don't see that information, or I don't see this communication, I need to give the server time to be able to make this communication. So what this dot then does is essentially it stops my JavaScript code from continuing to run from top to bottom, saying, hey, we need to wait for this response value or for the return value from the previous function to be generated before we can continue moving forward. All right, so the request is sent. Hey, can we talk? Yes, we can talk. Can I have the information regarding this Pokemon? That's happening here at this fetch URL. The server then queries the database. Well, JavaScript tries to continue running from top to bottom. So it moves to the next line on line 6. But it sees the dot then and says, oh, well, I have to stop. I can't just continue moving forward. And that's happening from that promise. Right here. It's being recognized as a promise. So JavaScript stops, takes a breather. Meanwhile, it stops. The server queries the database. Oh, I totally got those backwards. I put BD instead of DB. So let me go ahead and fix that here. All right, the database returns a query set to the server. The server then makes it into JSON readable information, and then it returns it. It says, here is the information you're looking for. So here's all the information regarding Pikachu. Well, first, we receive the response. That gives me all of my headers, including the status, where the response is coming from, etc. Although it's nice to have all that information, I don't need it. I just need the JSON readable information of the body. So I pass in this .json function. Now, this .json function needs some time to iterate through the entire response and put the entire response in a JSON format. So because it needs some time, again, we need to pause the script, utilizing the .then function, saying, hey, take a breather again. Let's wait until this response is generated. Once the response is generated, it gets passed as data, and we can see it being logged into the console. All right. Does anyone have any questions about this so far? Perfect. It doesn't look like we have any questions. I'm going to go ahead and add a division named container. That's where we're going to put our image of said Pokemon. So let's go into that. Let's go into const generate image. This is going to take in an image URL. All it's going to do is it's going to create an image. So we're going to say let image be equal to document dot create element ing. We're going to make this image source be equal to the image URL. And then we're going to grab that document. So document dot get element by ID container dot append child. We're going to append the image that we have created. All right, so this generate image function is pretty simple. Now I want to utilize it within this .data component or inside of this block here. Let's go back to Ajax. Let's send our request. here's what I get. I get back an object where it has the key of sprites, where it shows the front default information. If I were to open up this URL for this front default, it would show me the image for Pikachu. So now how do I iterate through this object to be able to grab the value of the key front default? And let me pass this one off to, let's see, Jason Belt.
I mean, I know we're trying to narrow down, I guess, from the initial name all the way down to sprites. I guess, do we need to scroll up or should I just index essentially sprites?
Oh, let's do that. Let's do console.log data at sprites.
Yeah, I feel like I need to see more to see the connection. Okay.
All right, let me go ahead and send the request here. Okay, data at sprites returns an object that has the following key value pairs.
Okay. So I guess we want front default.
All right, let me go ahead and pass that in as well. Front default. Let's go ahead and grab from Pikachu, and there it is.
Okay.
Awesome. So now we have the URL. We were able to find it. So let's go ahead and open up this body here. So now we can say, all right, let image URL be equal to the following. Again, I'm going to send my request. Perfect. Everything's working the way we want it to. What do I do with this image URL now? And let me pass that question off to Stephanie.
Pass it to your generate image function.
Nice. So I can do generate image and pass in my image URL. Let's see what this does. I'm going to type in Pikachu, submit, and boom, Pikachu gets generated inside of our script. All right, how is this happening? Well, let's take a quick moment to review everything that we've done up to this point. So first in HTML, we created a form with a division. This division is a container. This form has a get Pokemon function. It takes in some user input and it submits the file. Now within our form of get Pokemon, we prevent the default behavior of the form, meaning that nothing is being sent to our URL and my form isn't resetting my site. Great. Now the user types in their user input. We grab that input field and we pass in the value of the input field into this fetch Pokemon info. Now this fetch Pokemon info generates a request URL, which we're saving as a variable. It's just a string. Where did we get this request URL from?
The documents.
The document. All right. Could you be a little more specific? Which document?
The Pokemon API document, like the website. And
Yeah,
it has it right up there. Yeah.
perfect. So the Poke API gives me an example of how I can utilize this. I copied it to my clipboard, and I can see that the argument here is what Pokemon I'm looking for. I can put Pikachu here. And when I submit, it gives me all the information regarding Pikachu. Nice. Then we send a fetch request. Well, that fetch request breaks down to something like this. Can we talk? Yes, we can talk. Gonna have the information for Pikachu. The server then queries the database. It says, all right, well, I need to select all from Pokemon where name is equal to Pikachu. That then comes back as a query set. Then the server has to take query set and convert it to JSON readable information. Once it turns it into something that's JSON readable, then it returns it saying, here's the info you're looking for. Now, JavaScript is trying to continue to run from top to bottom. So what makes it stop? To give enough time for the server to contact the database and create this JSON readable data. What is it that makes this JavaScript file stop and wait for that data to return?
Is it the .then?
Perfect. So JavaScript is running from top to bottom, sends the request, and sees the .then. It waits for the return value of fetch and sets that return value as the variable response. All right, then it goes into response.json. Well, now JavaScript needs time to turn that response into a JSON readable data. So it stops again because we see another .then method. And then it takes the return value of this JSON readable data and saves it as the data argument that's being passed there. Excuse me, parameter that's being passed there. We then logged onto the console as we iterated through this data to be able to find the front default. And then we pass it into the generate image. So once the response is received, continues moving down all the way to generate image. It passes in the image URL. We generate a new image utilizing JavaScript. We set that image source to the image URL, and then we pass it into the container. Finally, completing our function. And actually, before we complete our function, let's go ahead and reset our user input field value back to an empty string. So now let's go into our application and look for Pikachu. Pikachu is generated. Look for Charizard. Charizard now gets generated. Let's look for Bulbasaur. Bulbasaur gets generated. And let's look for Eevee. Eevee then gets generated. All of this Pokemon information is being generated, all because it's already saved within the Poke API. I never had to generate this information, never had to go myself and find it. It was already within the Poke API. All I needed to do was capture my user's information so I could interact with this API and make my application that much more dynamic. Does anyone have any questions over this?
I have a little bit of a weird question. Can you scroll up a little bit?
Of course.
So it's taking me a bit to wrap my mind around line 11, 12, and 13, because usually the usual behavior that I understand for functions is that line 11, it's executing a set of instructions, but I'm assuming under the hood, there's got to be like a global variable that is capturing the response, which passes it in to then by making the first parameter connected to fetch somehow, because I get that the response from fetch becomes the first argument from then, but I'm assuming that's being done under the hood, because the way I would think to do it is to give fetch a variable and then have that variable go into then, instead of just it being done automatically for me.
Awesome. So what we're talking about here is the passing of information, right? How is it that this is being connected and what exactly is happening under the hood per se? Don't think about .then as its independent function. As you can see, it's dot and then. When we access something through a dot, usually that means that that is an attribute of a class, right? When we work within OOP and we're accessing the different classes, if we want to utilize a class method, we could call the class dot and then the method. Well, here in this example, fetch is representing our class. And this dot then is actually, oh, hello. This dot then is actually just an attribute of this class, saying then, or this method that belongs to the class of fetch named then can be triggered. And then inside of that method itself, we can call it yet again. So it's all one single line. I'm only indenting it for readability purposes. Does that answer your question there, Kenny?
Honestly, as soon as I didn't even put two and two together that this is a class, it just it really made sense.
All right, fantastic. All right, so now we were able to grab our request, we get our information. Now, the next portion that I want to talk about is what happens when the user puts in a ridiculous amount of gibberish there. Send a request. Well, nothing gets generated, and as we can see, we get a 404 error, meaning that something wasn't found at the following endpoint. So here we can see a GET request was sent to the Poke API for a Pokemon, but nothing matched that character space. And it returns a not found. Well, how do I handle for these errors? What I can do is I can type in a .catch. And this .catch will accept the error. And let's go ahead and take a look at this error here. All right, the request comes back. And when I console.log the error, here we can see this is coming from main.js at line 19. A syntax error, unexpected token n, not found, is not valid JSON. All right, so maybe there's something a little bit more descriptive here. Maybe there's like a message. And here in that message, we see that we are still getting this unexpected token, not found, is not valid JSON. All right. And then we could alert the user. So now the user can look for Pikachu. They can still look for Charizard. But instead of just breaking our site, when they click submit, they're getting, hey, you just gave us improper input. That didn't work. And not only did we give us improper input, but notice that our function didn't crash. It didn't leave the name inside the input field. It was actually able to complete its functionality, and we reset our input field back to an empty value. And that's how you handle for errors within request. All right. I'm not seeing any questions. I'm looking at the Zulu questions channel, and I don't see any questions as well.
Actually, I got one real quick.
Yeah, let's hear it, Jason.
Is this? I thought I remembered in foundations, like we were taught this method originally using fetch, but there was a more modern way to implement the same thing.
I believe what you're referencing to is a tool named Axios. We're going to be utilizing that once we dive into React, but we won't be utilizing that today. Does that answer your question?
Yeah.
Right, perfect. Async function method is more intuitive. We're going to be talking about async functions here shortly. Thank you, Morty. Okay, perfect. Let's go ahead and take a break. I want to make sure everyone has time to digest this information. I'm going to leave this up on the screen. If at any point anyone needs me to scroll through some code, please let me know. But as of right now, it is 10:32. Let's take an 8-minute break and come back at 10:40 to continue on with asynchronous functions. Thank you so much, everyone. All right, everyone. We just went over how to grab information utilizing fetch. Now, fetch works just great, and we're utilizing the .then method. Now, there is a newer way to be able to send this request, and this is going to be with an async and await function. So I'm just going to create this function in JSON. I'm going to show the functionalities. So async fetch Pokemon info. Everything is going to be almost exactly the same with a little bit of syntactical sugar, but the functionality will remain pretty much similar to one another. So I'm just going to go ahead and copy the body here. So I'm going to grab that request URL. The request URL is being made. Now, I believe it was Kenny. You mentioned making a form of a variable to be able to grab information. And we can say, hey, I want to let response be equal to fetch. And that will take care of this portion here. And then we can say let data be equal to response.json. And that will generate our data, taking care of the following information. Now, everything here looks pretty similar to what's happening in the function down below, with the exception of my try and catch block, which I guess I could always do try. Bring that down below. And then add a catch block there. All right, so now our functions look pretty similar. We have try and catch blocks, or a way to handle if there's an error that is to be risen. But there's a little bit of a functionality difference. Can anybody tell me? So what is the difference between lines 24, 25, and 26, and the functionality between line 11 and 12? What's missing?
Is it like the pause? Because then is breaking it and waiting for the responses.
Exactly. I need a way to tell my function, hey, you need to stop here, right? Because again, if we take a look at our stack, when this request is being sent to request information, the server needs some time to generate this query set in JSON and return it to the client. So I need a way to tell JavaScript, hey, you need to stop here. You can't just continue moving forward. So how do I account for that? Well, I'm going to add the keyword of async, telling this function that it is going to happen asynchronously to my application. And it is going to await for fetch. That await is what creates the pause. And then it's going to await for that response to turn into JSON readable data. So now instead of utilizing this fetch Pokemon, let's use this async fetch Pokemon. And let's see if there's any difference. Put Pikachu, nothing happens. Charizard, everything's working exactly the same. And if I send a bunch of gibberish, we get that improper input for handling of the error. All right, same exact function. There's really no difference as far as functionality goes. It's just syntactical sugar, and you need to account for that pause. The way we account for the pause in async functions is with the await keyword, and the way we account for the pause in regular fetch functions is with the .then. Now, an important and very key difference is that the .catch method will catch the error at each level. So if we have multiple requests being sent nested within each level, the .catch will be triggered as soon as that happens, as soon as the error is risen. Where up above, it's going to try the entire block of code before it raises an error. So there's just the key difference between how the error is being handled. And that's the difference between try and catch, and then utilizing .then and .catch. Now, as far as which one I recommend, myself personally, I like utilizing async and await just because of the fact that it's a less code that I have to write. Now, if I have a very complicated function with multiple requests being sent, I default to the .then method because it gives me independent control over each request. It's more of a design choice, but it is extremely important that you are familiar with both methods of sending this request. Does anyone have any questions over async and await versus fetch and .then?
I'm not too familiar with the .then stuff. I mean, I've used it before, but I've been told that when you use async and await, the request and all that stuff can happen asynchronously with for our example, the website. So does the fetch.then also allow the website to keep going, or does it literally just pause until the fetch.then is done?
That's a great question. So the asynchronous function will allow the website to keep going. This .then will pause the specific script or the specific function, not the entire site, but the function itself from keeping on going. So if there's other elements within your site that are dependent on this function to be able to render, then the site will have to wait until this function is rendered, right? The .then will pause the function itself. Asynchronous will just allow everything to continue without any problems. Does that answer your question now? All right, I see the thumbs up. Okay, perfect. So there's our Pokemon exercise. And that concludes our introduction portion to fetch and making Ajax requests. We interacted with the Poke API. But now let's go ahead and tie the knot. We have our Python server, which if we open it up, we can take a look that it is returning the information from the database. Here in my project, I still have the student CSV file. I have the schema that we've created. Nothing that we really need to dive into, but in the server, you can see that I'm grabbing the students from my database utilizing SQL Alchemy, and then returning a list of dictionaries. If I go to this address here, I can see the list of, I can see the array of objects being logged into my console. Now I want to tie the knot. I want to be able to interact with this project utilizing this HTML document. Well, this HTML document, I'm just going to simply add a UL with an H3 header of students. And to this UL, I'm going to give it an ID of student holder. All right, let's make our function for grabbing the students. So I'm going to go ahead and call const get students. I'm going to make this an asynchronous function just so that we could see more of it. And I'm going to go ahead and grab students. So I'm going to say, hey, let response be equal to await. And I'm going to fetch from the URL that we just spoke about. All right, so it's going to grab students. It will then make them into JSON data. So data be equal to await response.json. And for now, I'm just going to console.log data so I could see it. Let's see what happens when I try to send this request. I'm just going to simply trigger my function get students. Well, when I try to send this request, I'm getting an error. this error is telling me, hey, there's access to fetch at front end, students, etc. And it tells me it has been blocked by CORS policy. CORS, that stands for Cross-Origin Resource Sharing. If we take a look at our server, my server is telling me, hey, we are completing this request with a status of 200. So my server is responding, but it's my browser that's blocking the communication. It's saying, hey, this isn't something that is allowed to speak to each other because they're from two separate origins. It tells me that my HTTP or my local machine at port 63947 is trying to contact port 8000, and since they're from two different origins, it needs to be blocked. So how do I account for that? Well, I'm gonna go ahead and kill my server there. And what we're going to utilize is something called Flask CORS. This is essentially going to allow your API made with Flask to interact with different front-end applications. And this will allow for cross-origin resource sharing. Now, the way I do this is pretty simple. It gives me an example on how to install Flask here. It tells me, hey, utilize pip install. And I can even just copy it. You'll see that my virtual environment is already activated. So I pip install -u Flask CORS. Tells me my requirements are already satisfied. I'm gonna go over to my server application. Then I'm just gonna follow this example here. Tells me, hey, well, from Flask CORS, I want to import CORS. This is going to allow for cross-origin resource sharing. And it allows that by passing it into my app, or passing my app into this class as a parameter. All right, so that should allow for the communication. I'm gonna run my server one more time. Come back over to my site. I'm going to refresh the page. Well, now when I refresh the page, I'm not getting any errors. I see that my server was able to process a GET request at students. The response was successful. And if I take a look at my console, I have an array of 6 objects, all coming from the database that I created using my SQL schema and from the server that I created utilizing Flask with Python. Great. So my get students function is working. I'm able to generate some students and I'm able to see the data. Now I can iterate through the data. So for let stud in data, I can say, well, I want to create an li. So let li be equal to document dot create element of list item. And for every list item, I just want to simply display, let's just say for now, the first name and age of a student. So let's do li.inner text be equal to, do a little bit of interpolated string there, do stud, and then pass in stud dot first name, and then age, which is going to be stud dot age. Finally, I'm going to add that into my container, which in this case, the container was student holder. I can grab that from above. So let holder be equal to document dot get element by ID. That gives me the student holder. And I can say, well, holder dot append child li. All right, I'm getting a bunch of undefineds, and that's probably for the way I iterated through this stud. Let me go ahead and console.log what exactly stud is representing. All right, so that's representing the index. Might be because of this in. I need of instead of in. There you go. And now we have all the information there being rendered. So students are being generated. As soon as my application renders, everything else still works, nothing broke, but now I have my full stack lifecycle. As soon as my HTML template renders, notice my HTML template doesn't have much code. It just has my unordered list with the ID of student holder and H3 of students. But all of these students are being generated because my JavaScript file sends a request to my server. The server accepts this request at the following URL pattern, queries the database to grab all of the students, turns them all into JSON format, and then returns a JSON response, which is an array of objects. That array of objects is then interpreted into data. We grab the holder element, which is just the unordered list, iterate through the data, and for every object inside of that array, we generated a list item where we dedicate it to each independent student from the database and append that to the unordered list. And that's the full stack lifecycle. All right. Does anyone have any questions over any of the material that we covered today?
So for our server that is sending back a response, we have to specify that we're sending back JSON, so it doesn't send like the website URL.
I may be confused by your question. You are always going to send back in your response JSON data, unless you're specifically trying to send something back, such as like HTML coming in from your backend server.
Okay, yeah.
All right. Any other questions?
Yeah, so line 48 didn't work because you were iterating through a list. So when you changed it to of, that allowed you to go through the JSON objects.
So it was an array. If you utilize in, it returns the indexes. If you utilize of, it returns the value of each.
Yeah, that's kind of what I was trying to get at. Yeah.
Yes. Awesome. Thank you, Jason.
Is that specifically like so using of and then in a list, like looping through lists using of, is that does it return the sorry, I got that mixed up. If you use let student in data and then you like console log and it's printing the index, is that printing the index only if it's a dictionary versus like if it was an integer, it'd be printing the actual number? Or is that for like everything?
That's a good question. And no, when you utilize in, regardless of the data structure within the array, the moment you use in, it is always going to return the index. If you use of, it will return the value. All right, there's head nods. Fantastic. Perfect. It doesn't seem like there are any other questions regarding today's material, so I'm going to go ahead and stop our recording.